Hi, we need to find the square root of this complex number. Well, there is a bit of proof that lies behind this method, but I'm not going to go through that. Just give you a bit of an insight to what it is. We have that the square root of 3 minus 4i is a complex number, and 3 minus 4i is the square of a add bi, which turns out to be a squared minus b squared add 2abi. Now, we look at the coefficient of I, which is -4, and from observation we know that AB is normally half the coefficient of I, which is -2. Now this is only going to work when A and B are integers. So A and B are integers. So it can only be useful when A and B are integers. So we now can work out what the possible values of A and B are. They can be 1, minus 2, or 2 and minus 1. And we can check that. If we look at 1 minus 2i, and we square that, we'll have 1 squared minus 4i add 4i squared, which gives us minus 3 minus 4i, which we can write as minus 3 add 4i. And if we have 2 and minus 1, we have 2 minus I squared, which works out to be 3 minus 4i. So the square roots, one of the square roots of the root 3 minus 4i is 2 minus I. This one is 2 minus I, and the other is 1 minus 2i. And we can write this as the square root of 3 minus 4i is equal to plus or minus 2 minus I. You can check this for yourself. Just square both sides here. So this will just give you 3 minus 4i, as what I did with a check here. And you square this in brackets with a positive sign first, and secondly with a negative sign. You should get 3 minus 4i in both cases. I'm Alistair. Thanks for watching. And again, this will only work where A and B are integers. Hello there. Find the complex factors of this quadratic expression. Well, first we need to solve the equation x squared add 4x add 5 is equal to 0. And the reason we're going about finding the solutions to this quadratic is because we can then apply the factor theorem to find the factors of this complex, or the complex factors of this quadratic equation. Now, bear in mind that b squared minus 4ac here is less than 0. So we'll have a negative result in the square root, which we can express using complex numbers. Now we have x minus b plus or minus square root 4 squared minus 20, which is 4ac, all over 2a. And this gives us the roots minus 2 add I, or we have minus 2 minus I. Now, the factor theorem, if f of a is equal to 0, it follows that the factors, one of the factors of f of x, which is x squared add 4x add 5, is x minus a. Now we know that f of a must equal to 0 because these are the solutions of this quadratic equation. So if we substitute any one of these values of x, we equate this left-hand side to 0. So our factor is x minus a. We have a as minus 2 add I, and also a as minus 2 minus I. That's minus 2 add I. And the other factor is x minus 2 minus I. That is, if we clear the brackets, we have x add 2 minus I as one of the factors, and it was x add 2 add I as a second factor. Just to recap what we've done, we've turned this into a quadratic equation because finding the solutions allows us to apply the factor theorem. We have the two solutions for x, x squared add 4x add 5, which are these two values of x. F of a must be equal to 0, so the function is x squared add 4x add 5. F of a being either of these two solutions, and it must equate to 0 because there are solutions of this quadratic equation. And that implies that our factors would have this form x minus a. A in this case is minus 2 add I, and in the second case minus 2 minus I. So you have x minus a and x minus a to give us these two as the factors of this quadratic expression, x squared add 4x add 5. Thanks for watching. I'm Alistair. Right, next we have 7 minus 3a is less than 1. If we add negative 7 to both sides, then we have this. And the result is minus 3a is less than negative 6. Now if we multiply both sides by negative 1, we'll have 3a on this side and 6 on this side. But now that we're multiplied by a negative number, we must reverse the symbol. So now we have greater than. And now to get a on its own, we divide both sides by 3 to have a is greater then 6 divided by 3, which is 2. So if we were to plot this on a number line, we'd have values to the right of 2, not including 2. So a greater than 2. Next we have this inequality. Now let's try and get all the constants on one side and the letters on the other. So if we move our 2 by adding negative 2 to both sides, we'll have negative 3t is greater than t, add 1 minus 2. And the result of this is 3t greater than t minus 1. And if we were to move our t on this side over to the left, we'll have minus 3t minus t is greater than minus 1. So we have minus 4t is greater than minus 1. We'd like to have t on its own, so we'll multiply both sides by minus 1, and the result is 4t is greater than 1. But we must change our inequality. Now it's less than because we multiplied by a negative value. To get t, we divide both sides by 4, and we have t is less than a quarter. And here's another one. We have a half c minus 1 is greater than or equal to c. Let's deal with the c first. We'll add negative c to both sides, so we'll have a half c minus 1 be greater than and equal to 0. We can add 1 to both sides to get rid of this negative 1. So we have a half c minus c is greater than and equal to 1. And then we have a half c minus c, which will give us, 1 over c. Oops, I changed that. Mistake. So this should be a half c minus c is greater than or equal to 1. So we have a half c minus c will give us minus a half c, that's greater than or equal to 1. We multiply both sides by negative 1. We must change the inequality. So we end up at a half c is less than or equal to negative 1. If we want c on its own, we must multiply both sides by 2. So we have c now is less than or equal to minus 2. Let's have a go at this one. We have m, we clear the brackets, greater than 2 minus 2m. We'll move our negative 2m from the right over to the left by adding positive 2m to both sides. So we have m add 2m is greater than 2. If you add 2m to this side, it cancels to 0. Now we have 3m is greater than 2, so m must be greater than 2 over 3. And that's the end of this video. Thanks for watching. My name is Alistair. Don't forget to make any comments or ask any questions. Don't forget also to like, follow or subscribe for more videos like this. Bye for now. Hi, this is Harris Maths. Suppose you're given this inequality which represents the number of n CDs that were bought from, let's say, your favorite music store, and you're asked to rearrange this inequality to obtain n, which is the number of CDs, the maximum number of CDs that can be bought. Well, we proceed similarly to how we would tackle an equation. So we have 6.5n. First we'll add negative 4 to both sides. So this becomes add 4 minus 4 less than or equal to 1 minus 4. And the result is 6, which is less than or equal to 71. And n represents the number of CDs, the maximum number of CDs that can be bought. So we can find for n by dividing both sides by 6.5, get this less than or equal to 71 over 6.5. To get rid of our decimal, we can multiply the top and the bottom by 2. So we have n is less than or equal to 142 over 13. Now 142 divided by 13, 142 divided by 13 is approximately 10.9. So the maximum number of CDs that can be bought, maximum number of CDs that can be bought is 10. Thanks for watching this video. My name is Alistair. Please like, follow or subscribe for more videos like this. Bye for now.